Hello, my name is Vladimir Kropotov. This is Sergey. We're working for Positive Technologies, and this is a joint research of incident response and telco security department. And we will cover a fraud topic in the telco network, but we mostly focus it on the mobile phone carriers. And we will discuss the possible attacks because the thing that often happened, like telco operator come with us and tell us what we saw this kind of activity, how it's possible to make it, how it's possible to reproduce this attack, to understand the detection methods for this attack. So we're often doing something like reverse engineering, but not for the binaries, but for the fraudulent activities in telco networks. So fraud is something like services that receive it without payment, or like services when someone else paid for it. So what often happens on the telco networks, and the victims for the fraud are could be classified as a telco operator subscribers, like they paid for the services that they weren't received, like telco operator who paid for something what he didn't do, and even third parties, things like banking fraud that was implemented through the telco operator. So we will cover 3 cases. We separate the cases by the level. So for the level 0, it's a kiddies cases. It's just usual SMS with spam, with URLs to malware. It's a social engineering attempts to the direct victim, and another case is like a social engineering attempt for the telco staff. So the level 1, it's a kind of intermediate level. It requires some knowledge on the radio access network protocols, but it usually works locally around the area, like 100 meters from the victim. And the things like MCA catcher are related to this case, but the thing we're mostly focused related to the fraud cases that could be implemented from any part of the world, like sitting in Australia, you can attack subscribers in Southern America, and so on. So let's look at the lightweight scenarios. Here's example from Russia. So in Russia, we have obligatory obligation from the bank to inform the customer about any transaction with credit card. Like if you buy a candy to the girl for 20 cents, you will receive SMS about this transaction. And on the right side, you can see the legit SMS about 3 transactions. And on the left side, it's a case where type was quoting on the source address, and and the text means like you receive it like 500 euros, and you should click this link to confirm the transaction. So this is one of the cases of the social engineering fraud. Another thing, it's like often even Russian central bank is used in the social engineering attack. On the left side, you can see the real attack scenario where was like more than 25 millions of euros stolen after the letters on behalf of central bank to another bank. But even kiddies use this name and send SMS from the central bank. Central bank tells you that all the credit card you have are locked, and please call this number just to handle the situation. And another fraud activity, it's affected often old persons like grandma. So there was a bunch of the calls to the old people on behalf of the of the children, like your kid is on the road accident, and he needed money for surgery and so on. And old people provided all the details from the credit cards and lose like 100 or even 1,000 euros per time. So yet in our case, what happened with a researcher in IT field, so the guy received a call like, we will hack you, please be ready. And he turned it on like two-factor authentication everywhere. But the actor did the strange thing. He called the mobile operator and asked him to redirect all the SMS and calls to another number, like this number doesn't work, and please redirect. And in this case, researcher lost his Gmail account, Facebook account, and a number of messengers account, but all the stuff related to the kiddie stuff, because it's not required any technical knowledge on the infrastructure or the protocol. So yet now a scenario with middle level.
This screenshot demonstrates SMS interception on the radio track for GSM technology. Nowadays, this equipment is not expensive. It may be about 200 euro, and open source software installed on the Linux platform.
So in this case, the traffic was passively intercepted. So here is the similar case for the phone call, for the ongoing and incoming phone calls, and the message was decrypted. The decryption of the message took like a couple of minutes, so you can do it near the real time, and operator uses the same encryption key for signal data and for the voice. So if you was able to decode the signaling data, you can do the same with the voice call in the real time, but you have to be nearby the victim. So this case covers the interception with mid attack, but this case could be detected on the telco side, because usually when attacker intercepts the message, the data goes on the the data is not encrypted, so it's kind of untypical behavior for the modern telco network, but that's the way the attacker can act. So now we're going to the cases with global impact, where you can initiate the fraud, so the attacker can locate in any country and attack any another country. And Sergey will introduce the typical scheme for the telco infrastructure.
If we see on a modern telecom network, it consists of some different domains, a lot of protocols, a lot of technologies, a lot of different type of equipment. But I would like to focus on some of them. First, HLR. This is a database of all subscribers of a mobile operator. Another one, node VLR, visited location register. This is the database, the dynamic database, and it collects information about all subscribers who are located in some area which covered this node. One more node, MSC, Mobile Switching Center. This node processes all voice and SMS traffic. These two nodes, MSC and VLR, are working together. And if some bad guy malefactor crashes this node, a lot of subscribers may be out of service.
So it could so for the country region, or like for the country capital, all the subscribers could be out of the server. So it could be like 100,000 people who will be switched off if the system will be successfully attacked.
So to understand the telco terminology, I would like to show some identities, types of identities. First of them, MS-ISDN. This is just ordinary numbers which subscribers operate to call one another. The next identifier, GT, global title. This is an identifier of equipment, of core equipment of the subscriber, of the mobile operator, and it has the similar structure, similar to MS-ISDN. It has first several digits mobile code, 352, this is Luxembourg, then several digits of operator code, and the rest digits just to complete the number. One more identity is MSRN, mobile subscriber roaming number. This identifier is the same, and it is used to perform incoming call to any mobile subscriber. This number assigned for a short time, very short time, for during the call setup. And the last one, IMSI, International Mobile Subscriber Identity. This is a number of SIM card, which consists already from 3 group of digits. First 3 digits mobile country code, 270. This is a mobile country code of Luxembourg as well. It is differ from 352 because different standards of identifiers. Then group of digits operator in the country, and just the number. This identifier IMSI can be very interested to hackers because when they know this information, they can perform sophisticated attack on subscribers or telecom infrastructure.
So the telco infrastructures is like more ancient than the internet, and technologies that it rely on are built in the 70s. So there were no thoughts about security at this time, and the modern infrastructure, excluding the pure 4G networks, it's still dependent on the technologies that were built like 50 years ago. So what are the major threats in the telco network? One of the cases is call interceptions or SMS interceptions and spoofing. Another thing is like location tracking, which is very popular. And you can see a number of services in the internet which use it by cyber criminals and legit people. And of course, it's DDoS attacks to the actors, to the victim. So on our experience, about 80% of the network are vulnerable to the DDoS attacks, and there are 2 options for DDoS attacks. So you can take down the subscriber, and you can just starvate the balance of the subscriber. So you can just silently redirect subscriber to the primary services, and when took his balance into the 0, and he will unable to make a calls, and without money. So this is the old message. It's called send SMS, send IMSI. So this message doesn't need it for the modern networks, but many hardware equipment still reply on this message. So it's the preliminary stage for the sophisticated attacks what could be implemented by the actors. So for the scenarios, for the fraud scenarios are now experienced like 77 or 67% of the networks are vulnerable to fraud. And now we are switching to the particular cases. So it's often possible to manipulate the balance of the phone and transfer money from one phone to another using a USSD. But now the modern world, but in many countries, now credit cards are linked to the phone numbers. So in Russia, you can send money to the credit card by knowing only the phone of the recipient. So in the case of the phone balance, actors can steal like tens or 100 euros, and in the case of the credit cards, actors can steal thousands of euros. So here is the attack scenario for the balance transfer using USSD.
That was performed during the test program for one of operator. First step, this is request of balance of a victim subscriber. It had 128 rubles at the beginning of the test. Then we sent a command, USSD command, which directs to transfer 10 rubles to some number. But operator tried to protect, and they deployed a security mechanism. Just send this number *145*841# to confirm the transaction. If we performed previous two steps, we can send this command as well. And at the end of the test, we can see 118 rubles on the balance of the subscriber, 10 rubles. So get off.
So this attack implemented remotely from one country to another country. So it's not a local attack. So you can do it like from this country to attack any another country or continent. And that's the major problem. So in SMS, what you receive, like from the bank, you can the attacker and during the legit operation, it's possible to use numbers like phone numbers or use alphanumeric symbols, and this option allows attackers to impersonate the banks or the victim and send SMS on behalf of the persons of the bank or the banks. So here you can see money withdrawal with 3,000 US, and this is a fake SMS, but it looks like legit, excluding the ha sign inside because it was attack reproduction. So on our experience, almost all networks are vulnerable to this type of attacks. So maybe you saw a number of the headlines in the news about vulnerabilities, and now we will show the demo. This works for the Facebook, for WhatsApp, but we will show the Telegram case, so how to intercept Telegram messages on the phone.
At the beginning of this demo, two subscribers, left one and middle, just have a chat, test chat between one another. they interchange several messages. Okay, and now hacker starts. First, he registers the subscriber in a fake network and initiate SMS interception mechanism on its own equipment. Then he start a new Telegram client, enter a number of the victim subscriber. Okay, and Telegram waits for input code which it sends by SMS. But this SMS is intercepted by hacker, and here is the code. Just enter it. Initialization is going on. That's ready. Hacker can read all messages that was written before. This is everything the same. When victim's friend sends messages, they are received both on the victim and hacker's equipment. So now we can see dialogue, but this dialogue has 3 participants instead of 2 before. But Telegram Messenger has one more security mechanism, security chat, or private chat. And we now test, is it really secure thing? Victim initiate new secret chat and will send some message to his friend. Friend receives this message, but hacker does not. However, he can initiate a new secret chat and send to victim's friend some messages. In this case, victim friend sees this message in another secret chat. So one more secret chat.
So victim could be impersonated in this case, and the victim friend will never understand who he's talking with. So it's impossible to intercept the secret chat, but it's possible to impersonate the victim in the secret chat. So now we will show the case when 2 subscribers located in Luxembourg calling each other, and what could happen if intruder will manipulate this session with this local call.
So we assume this intruder is located in Zimbabwe with the prefix 26. And first he sends update location message. This is emulation of outbound roaming of this subscriber. Malefactor should know IMSI of this subscriber, and he sets up one more parameter, MSC and VLR address. He uses this one. After this operation, HLR database starts to think this subscriber, this one,
on the
goes to Zimbabwe, and he operates there. When somebody calls this subscriber, signaling message comes to the gateway MSC node. Gateway MSC does not know where this subscriber is located, so it asks for HLR, send routing info message. But all we remember this signaling exchange. After that, HLR asks mail factor for subscriber location. What mail factor can do? He replies to this message, but he pointed out location Luxembourg, not Zimbabwe, but Luxembourg. And this information is transferred to gateway MSC. After that, gateway MSC starts charging of this subscriber. He thinks this subscriber is in Luxembourg, and he receives a mobile call. So this suggests no charging. This is free for the subscriber. Just continue a call. After that, JMSC send routing info message one more time to the HLR, but HLR knows where this subscriber is located. He asks to mail factor, provide roaming number. This is identity I mentioned before. But what mail factor does? He sends number with some another prefix, 52. This is Cuba. And this number goes to gateway MSC. Gateway MSC just route to this direction. This may be ordinary call or premium rate number. If this is premium rate number, there is a question: who pays for all these premium rate services? This subscriber makes just a local call. He pays for
call inside the country.
For call inside one network. This subscriber is out of billing. He receives a mobile incoming call from the point of view of a billing platform. Operator pays for all this premium rate traffic. And if this guy is in one team with our mail factor, they can earn a lot of money. So in expense of operator.
So any ordinary call could be handled like this way through the primary services, and the operator will pay for the fraud because neither caller or recipient should pay from the billing point of view. So that's all the cases. If you have questions.
Hi. So, any questions? Any questions in the room?
Yeah, thank you. Approximately how many times do you witness such frauds in current networks?
So this thing's not going to the public usually, but several times a year, many telco operators ask us to investigate the cases like this. So it's not the public, but the things that are really happen, and that's the fraud that hurts to the telco operators.
Thank you.
Any more questions? Oh, okay.
I think there might be a comment about prerequisites to implement this type of attacks, because it requires a special access, and maybe Sergey have a couple of notes about a requirement to implement attacks to SS7 layer.
To implement these attacks, a mail factor, or for example, we as investigators should be located inside any mobile operator, and we should be connected to the SS7, to the signaling network.
So if you have access to any mobile operator over the world, so you can buy like for 500 euros somewhere access in South Africa or somewhere else, you can implement this type of attacks to any country, to any telco operator. Okay, thank you very much.
Thank you.